All right, last thing before the quiz. How do I find an angle on the outside? Angle on the outside of the circle now. Before I do that, though, I want to introduce you to a new line in the circle. What was it, Monday? I introduced you to a tangent. How do you know a line is tangent to a circle? That's my first question. Review question. How do you know a line is tangent to a circle? 1-9. Here we go. Sean, how do I know a line's tangent to a circle?
It intercepts the circle at only 1 point.
Exactly 1 and only 1 point. But now I have a line that intersects in 2 points. That is called a, anybody want to try to pronounce it? Secant. Correct, secant. That is called a secant. A line that intersects the circle in 2 spots is called a secant. So what I've created up here is 3 circles. All of them have an angle on the outside. But they were created 3 different ways. How was angle B created? What are A, B, and BC? Those are tangents. All right, so I created an angle on the outside using 2 tangents. How did I create angle A on my second diagram? 1 tangent and, what do I call that bad boy again? 1 secant. 1 secant and 1 tangent. And I created an angle on the outside a 3rd different way, using 2 secants for the 3rd diagram. Here's the good news. I don't care how that angle is on the outside is formed, we find it the same exact way. Angle B, angle A, and angle A up on my 3 diagrams are all going to be found the same exact way. Angle outside the circle. I don't care if it's 2 tangents, a tangent and a secant. Do not care. They're going to be formed the same. They're going to be found the same way every time, and that is, I'm going to take half. What did we do for a floater angle yesterday? Half of.
It's arc.
And what did I do with the 2 arcs? Add them. You want to find one on the outside? Subtract them. All right, so I'm going to take half of difference, meaning subtraction, difference of its intercepted arcs. So whatever arcs are in between, I'm going to subtract them. Here's exactly what I mean. Let me take the first 2 diagrams. Take the diagram with 2 tangents. How would I find the measure of angle B? I would take 1/2. What's the bigger arc in between angle B? I would take arc ADC and subtract, what's this minor arc, the smaller arc in between angle B? AC. There you go, guys. That's how I would find angle B now. And just to make sure we're good, go to my second diagram. How do you think I would find angle A? 1/2. Make sure you take the arcs in between. That's important. Yes, arc BD minus arc BC. All right? I don't care how it's formed. If you tell me an angle's on the outside, our discussion is done. Done. I'm going to subtract the 2 arcs in between and take half of that. Done. All right, that's how I find an angle on the outside. Any questions on finding the angle on the outside? Anything you want to talk about? Because now there's always like exceptions to the darn rule, right? Well, there's unique angles we need to talk about. Well, Mr. Carlino, they're not inside and they're not outside. They're kind of in between angles. Take a look at the next one. An angle formed by a tangent and a chord. Can you tell me that's inside? Could you tell me it was outside? Me neither. I can't say it's inside or outside. It's kind of in between, right? So in this case, an angle formed by a tangent and a chord, some of you guys would have loved to know this last night. Would have made your lives a lot easier probably. It's going to be half its arc. Very similar to an inscribed angle. Half its intercepted arc. Okay, half its intercepted arc.
What angle are we? What angle?
We could be talking about either one. I'm going to talk about angle CAB, but I could be talking about BA on the other side. I just don't have another letter for it. So if you wanted to find angle CAB, you take half its arc measure. Chord and tangent. Chord and tangent. $70 degrees. A little tweener angle if you want to use the street lingo. Not inside, not outside. All right, another in-between angle, and you guys are going to hate this. Not that you don't hate everything already, all right, in this unit. An angle formed by a secant and a chord. Ugh. This angle right here I'm talking about. Is it inside? Some of it. Is it outside? Some of it. You ready for the rule here?
Oh, I'm excited.
Oh boy.
Yay.
There's no rule. It's not like you take half the arc. It's not like you add this and take half of that. Nope, there's no rule. But I'm still going to have you find it. And you're not going to use the excuse there is no rule. You know how to find that angle. Look at the diagram for me. Look at that diagram. You tell me how to get to that angle. Sure, you're not going to take half the arc, but you can still get to that angle. Look at the whole diagram now. Some of you guys probably did this last night on your homework. Radhika, how am I going to get to that angle?
It's supplementary to an inscribed angle.
Hey, look at the one next to it. It's inscribed. Everyone in this class knows how to find an inscribed angle, maybe. Once you find that inscribed angle, it's supplementary, and now you can find that angle formed by a secant and a chord. All right? So yes, it doesn't have an official rule, but you can still get to it. All right? Questions before we dive right into this? All right, let's roll. Let's roll. Woo! Find angle CAB, and I should have got rid of this. This is embarrassing. I get it. It's the same question. It's the same one I just put in the darn theorem. I get it. Sorry. All right, I got to take it off next year. But do we see angle CAB? What is CA? What do I call CA in the circle? Tangent. And what's AB? A chord. So it's an angle formed by a tangent and a chord. My rule says I take half the arc. So I'll take half of 140. 70 degrees. All right. Questions there? All right, number 2, arc AB. Which one am I talking about, right? Minor arc. Minor arc AB, everybody. Find smaller minor arc AB.
How would we know that?
I would probably do one of these bad boys.
Okay.
And then now I'm going to say AB. If I wanted the other one, I put ADB. Yep. So how do I get to minor arc AB here? If I just give you the 160, formed by a tangent and a chord. Oh boy, here we go. Let's start calling on you peeps. 2-4. Emily, good morning, Emily. I got 160. Can that 160 lead to anything else, Emily?
You could do 180 minus 160.
Okay, so you get the angle next to it is 20. And now what could I do with that 20, Emily, to find minor arc AB?
Multiply it by 2.
Great job. Great job. Because usually I would take half of it to get the angle, so go backwards, I'll double it. Nice job, Emily.
How would you know that 160 is like the angle, not the arc?
Probably because if it was the arc, I'd probably put it somewhere over here.
Oh, okay.
Okay, just to make sure it's right on the arc. Okay. All right, you ready? 3. I'm looking for angle X. First question I'm going to ask you every single time, inside or outside? Okay, or we're done. We're done. I got no more questions for you. If you tell me the angle's on the outside, it's found one and only one way, by taking half the difference of the arcs in between. Every time. So 90 minus 20, half of 70. That angle's 35 degrees. Questions? All right, now it's going to get a little more. That was a basic one. And I just go right to the top now on this next one. Where's 38? Outside, right? So how did I find 38? I took half. I'm just going to color code it for now. I'm taking half of this orange arc minus X, right? That's how I find that outside angle. Half the difference of the arcs in between. Oh boy, guys. How do I find the orange arc? I already got 140 down, right? 140, done. How many degrees are left in the entire circle if I already put 140 there? 320? 220, right? 360 minus 140 gives, so I have 220 degrees left for the rest of the circle. I took up X right here. How can you write what's left now? 220 minus X. Everyone good? I had 140, so 360 minus 140, 220 degrees left over for the rest of the circle. Well, that piece is X, so the final part's got to be 220 minus X minus the smaller arc, which was X. We talked yesterday. I don't care how you solve this. If some of you guys want to distribute the 1/2, go ahead. If some of you guys want to multiply both sides by 2 instead, go ahead. I don't care. And I'm hoping we're getting 72 degrees. Okay. Ready for this last one? Where's the 60?
Outside.
Okay. So ready? 60 outside has to be equal to half of 2 arcs being subtracted. Here's your bigger arc right here. Minus X, the smaller arc. What's the deal with the bigger arc?
360 minus.
There's 360 degrees in a circle. If that piece is X, the rest of it is 360 minus X. Anybody at home? Any questions here? Little bit. I got to challenge you guys more than just actually giving you the arc measures like I did in number 3. You got to be challenged more than that. Same thing. Distribute the 1/2 or multiply by 2. Whatever floats your boat. Find your loss remote. 120 for arc X there, 120. How's everyone doing here before we get to the crescendo here? And, you know, this is great that, you know, and I'm happy you guys if you feel confident when you can just do a problem by itself, but this is where I need you to be, these multi-part questions. Wow. A through F, I'm sorry. Wow. A through F, I'm sorry. Remember, we don't care about it yet. I want you to try to find as many arc measures as possible first.
Oh, is
What?
that AB supposed to be?
AEB. AEB, yep. AEB. So if anybody wants to add a little E in between there, yes, arc AEB is a 150. 150. EOD, you got yourself a diameter. Wow. That's it? I don't think I can find any more arcs here. Oh, wait a second. Ready? I didn't read something in the directions, did I? Got to read everything. There's a reason why I gave you AB congruent to AD. What are they? AB and AD in the circle. Those are what? Okay, congruent. Thank you. Thank you for that. Appreciate it.
Chords.
They're called chords. They're called chords. There's a theorem I gave you way back in the beginning of the unit. If two chords are congruent, that implies they're arcs. Oh, arcs are congruent. Everyone at home, yes? If two chords are congruent, so are the arcs. So what arcs are congruent? Let's see. Chord AB belongs to arc AEB. I got that as 150. AD belongs to arc AD, which also must be 150. Let me write that all out. You don't have to, but let me show you what we just did there. Because the two chords were equal, arc AB is congruent to arc AD. Congruent chords imply congruent arcs. That's what gets us kick-started here. Here we go now. Tell me another arc you know. Let's roll. Let's roll. What other arc measures should you be able to label now? BD and EA. Right? What's EA? 30. If anybody wants to know why, that's the diameter, makes a semicircle 180 degrees. What about arc BD? Ooh. Oh, hold on. Okay, let's back up now. What about EB? Arc EB. Because I do want to find the measure of each individual arc here. So I got EA, I got AD. How about EB now? 120. Because it added to 150, right? Now find BD. 60. Half a circle, 180 degrees. Try to find each individual arc. Do I have them now? Do I have each individual arc? Okay, hopefully now this is going to be a little bit easier. Okay, everyone get ready because now the numbers are going to fly out. AD, I'm not going to ask anybody. That's 150. Ready? BAD. BAD. I am going to go through the same set of questions with everybody, every time. 11, here we go. Anthony. Angle BAD, inside or outside?
Inside.
Inside. So ladies, gentlemen, if it's inside, it's one of three types. Anthony, is it central?
No.
No, done. Inscribed?
Yeah.
Done. Inscribed. All right? So the rule, Anthony, is what for inscribed?
Half of the arc measure.
Which is what for angle BAD?
60.
Kids on fire. Half of 60, 30. Probably put it in your diagram too, might help. 30. Nice job, Anthony. Everyone okay so far? All right, let's keep this rolling. Part C. And I should probably write this out down here so you guys can see the work. ACD. ACD. 13. Here we go. Sophia, ACD, inside or outside?
Outside.
Okay, my questions are done, aren't they? There's only one way I find an angle on the outside. Here you go, Sophia. 1/2 of 2 arcs being subtracted. What's the bigger arc in between ACD?
150.
Minus the smaller arc, which is?
60.
Done. Once she said outside, I knew the rule. So we're going 1/2 of 90. 45. So this angle up here, 45 degrees. All right, let's keep trucking. Part D, the measure of EFB. We got this now, EFB. Everyone find it? All right, number 9. Audrey, you're up. Inside or outside, EFB?
Inside.
All right.
No, floating.
No, you were right. You're right, inside. You're right, it's inside. So now I go, it's 1 of 3. Is it central, Audrey?
No.
Is it inscribed?
No.
So my only choice is it's a
Floater.
floater angle. Got it. How do I find a floater angle, Audrey, from yesterday? 1/2. What do I have to do to 2 arcs?
Add them.
There you go. All right, here you go. Which 2 arcs? What arc belongs to EFB and what's its measure?
120.
Good. And its vertical angles arc, which is how big?
150.
There we go. We're getting this. So I got 1/2 of 270. 135. Good work, good work. Part E. EDA, everyone. EDA.
Sorry.
Question, yes.
I have a question on D.
Yep. Floater angle.
I added 150 and 150. Is that wrong?
120 and 150.
Where's the?
What you have to add arc EB plus the vertical angles arc AD.
Oh, I had the wrong marking down for the 150 degrees.
Okay.
I didn't think that was AB. I had it down as.
Yep. EB is 150. I just needed to take EB. Okay, arc angle EDA. Top of the page, Vinny, here we go. EDA, inside or outside?
Inside?
Okay, central?
No.
Inscribed.
Yes.
Got it. 1/2 of what arc, Vinny, if it's inscribed?
EA?
30, got it. 15 degrees. Now, hey, we talked earlier on the homework. Let's say Vinny didn't know it was inscribed. 135 was vertical. I could put 135 there and then do the 3 angles in a triangle to get there. Ooh, and then we get the last one. Who am I going to catch on this one? Angle EDC. EDC. Vinny, I already talked to you. I want to hear some new people here. 2s. Hannah, good to talk to you. 23. Luke, here we go, Luke. You ready?
Yep.
Darn right. Yeah, I can tell you're so enthused. EDC. Is it inside?
No.
Is it outside?
I don't know what it is.
Yeah, of course, yeah, because some of it's inside, some of it's outside, right? It's kind of one of those between angles. Luke, what's OD? What do I call OD in that circle?
Is that a radius?
It is good. And what do I call CD?
Tangent.
I think we got a theorem for that, Luke. Don't we? If I draw a radius to a tangent.
I don't remember.
Yeah, you do. If I draw a radius to a point of tangency,
Is it 90 degrees?
it is perpendicular, forms a 90-degree angle. Got it. Now, if some of you didn't remember that theorem, This is a tangent and a chord. You could have taken half of its arc, which would have been 180. So you could have done half of 180, 90 degrees as well. Questions there? All right, looks like I'm going right up to the bell here today. Perfect. It's not too often we do that. Not a multi-part question. LZ is 56. Arc LZ, 56 degrees. What's the measure of angle P? All right, you know what my first question is going to be. 5, Hayden, is angle P inside or outside?
Outside.
Okay, our discussion's over, Hayden. The only way I find an angle on the outside is I take the bigger arc. Bigger arc? Hayden, can you help me find arc EZ? Because that's the first arc I got to write down. It's because it's going to be arc EZ minus 56. How do I find arc EZ here?
Arc EZ would be 180 minus 56.
Good job. Good job. That's a diameter, so a semicircle. So what's that? A buck? 124? Anybody? 124? Oh, that's easy. Okay, nobody got that one. All right, that's easy. That was the arc name. Oh boy, you guys are just so hungry and focused. I understand. And then somebody's got to help. What do we got here? 125 minus 56. 68. So I got that one. Thanks. Appreciate that one. 34. Yep. From the same kids who needed to know what was the average of 86 and 88 yesterday. Questions? What?
We were in class. Yeah, we were online.
I'm sure you're using your calculators at home though. Let's be real. Let's be real. All right. Yep. 86 plus 88. All right, guys. Good job. Do not do the homework tonight. We'll have a ton of time in practice tomorrow to ask questions. Have a good night. What? How you guys luck out this year?
Yeah.
And now I have to find like 2 weeks of stuff to do.
Yeah, we should just watch a movie.
Yeah, we should. Well, maybe we'll just go out do like some tug of war or
I would like
water balloon toss, Disney bat race, the old field day. Why not?
I would love
Why not?
They're canceled. If we have a final happening,
I know, I
private
know.
class, like if they cancel regions,
I was
but they don't
telling-
cancel finals. Will you make will you make our final like harder than the region test?
I don't know what the rules are because they said they canceled final exams. So I don't know if I can give like a 4-day
a cumulative
test
You know what
that
other
counts for quarter
classes
4. I don't know yet. I got to figure that out.
Do I have one?
I would like to, yes, but
Would you make it more difficult in the regions?
I would make it I would probably make it a Regents exam that you took over, so you guys actually.
Because the regions is like the normal level, but we're in the like honors class, and then you have like.
But you guys have never taken a Regents yet.
We took the midterm.
Not the same.
Really?
Yeah.
All I
Yeah.
remember is that we got to eat a ton of Jolly Ranchers while you're in the building.
Oh. Hunter,
Well,
what do they only have smalls in the Alfred bookstore or what? Jesus Christ.